All right. Today we're going to look at box and whisker diagrams, also known as box and whisker plots. You have seen this in ninth grade and probably in your fourth level math if you took AFM or anything like that. So, the first thing that we want to get into is the fact that a box and whisker diagram or plot is a visual display of some of the descriptive statistics of a data set. It shows the minimum value, the lower quartile, which is Q1, the median, which is also called Q2, the upper quartile, which is Q3, and then the maximum value. So, anytime we have those five specific numbers, we call those specific pieces the five number summary. So, if anybody ever asks you to find the five number summary, you should know that they're saying find the minimum, the maximum, the median, and then your lower quartile and your upper quartile. Okay, so when we do that, it will look like this. And of course, there will be numbers as well as number lines for this. Okay, so those numbers will go there. So, interpreting a box plot. So, remember when we have things that are positively skewed and negatively skewed when we're talking about histograms? Same thing with your box plot. Anytime it looks pretty much even on the left and the right as far as your whiskers and your box, um, then you already know that it's going to be symmetric. Okay, that is pretty much going to be identical almost. Positively skewed is when majority of your data is pushed to the left. So as we can see here, majority of the data here is pushed to the left. And when I say majority, this is what I mean. So let's take a step back real quick. You have four pieces to your box and whisker plot. You have a whisker on each side, so there's two of the pieces, and then you have your big box that's divided into two parts. Each part of your box and whisker plot is worth 25% of your data set or of your distribution, so to speak. So when I say positively skewed, when I say if it's positively skewed, majority of your data is pushed to the left, then as you can see here, I have 25%, 25%, 25%. So as you can see, 75% of my data is pushed on one side, okay? If I look at the negatively skewed, same thing. Negatively skewed means majority of your data is pushed to the right. So I have 75% here. One, two, three pieces that's pushed to the same area, so to speak. Okay? So this is an example of what symmetric, positively skewed, and negatively skewed distributions will look like in a box and whisker plot. So in order to draw a box and whisker plot, you have to know the you have to know the minimum, the maximum, the median, and the two quartiles, your quartile 1 and your quartile 3, lower and upper. So we already know how to do this by hand. I'm not going to insult your intelligence to tell you to do it by hand. Okay? You can look at your previous notes and do it by hand if you want to. We're going to use a calculator for this. So remember, in order to find this stuff in the calculator, you're going to type your numbers in. You do not have to type them in order. The calculator will do all that stuff in the background. Okay, so here I want to make sure I have enough numbers. It says I have 16 numbers. Let me count them up. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Okay, all my numbers are there. So what I'm going to do is I'm going to go to stat, go over to calc, press number 1. Your frequency list should be blank. You don't have any frequencies. And then we're going to scroll down until we get the 5 number summary. The 5 number summary is the last 5 things that you'll see. And if we see here, we can say that we know that our minimum is 2. Our Q1 is 2.5. Median is 5. Q3 is 6. And the max is 9. So if we want to plot this, we always use a number line. So if I have 2, 3, 4, 5, 6. Okay, So let's say I want to start with 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay, so my minimum is going to go where the 2 is. My maximum is going to go where the 9 is. My Q1 is 2.5, so that's going to be right here. And I'm doing this by hand, so it's not going to be perfect, but you get the gist. My median, my Q2 is here at 5, and then my Q3 is at 6. So I'm going to connect that in the middle to make my box, and then I connect my whiskers. So as you see here, this is going to be, if we look here, we can tell that this is positively skewed. Okay, just by looking at it. Just wanted to throw that in there. Okay, so it's positively skewed. So that's the way my box plot will look. The next thing we want to look at is we want to look at outliers. So outliers are numbers that are outside of where the normal or where the rest of the numbers are. So let's say the best way to think about outliers is thinking about grades. So let's say you are a AB student. Let's say you've been making 80s and higher. Those are your grades. And let's say you had a bad night of studying, you were tired, you got sick, you could not study. Let's say you ended up making an F. That F is technically an outlier because it's not a picture of what normally happens or what has been happening historically. So, of course, we just can't just look at a number and say, oh, well, that looks bigger than or small, way smaller than everything else. We actually have to have math behind it. So the way that you find out what your outliers are is you have to find the upper bound and your lower bound of your data. So what you have to do in order to find the upper bound is you have to find the upper quartile, and then you have to add 1.5 times your IQR. Lower bound is the same way. You take your lower quartile, but you have to subtract 1.5 times your IQR. So once you know what your outliers are, then you will mark it as an asterisk, like a little star on your box plot. So let's look at example 2. Example 2, the first thing we want to do is we want to identify any outliers first. So once again, let's put everything in a calculator. Okay, so I should have 20 numbers. Let me make sure I have 20. Okay, I have my 20 numbers typed in. So then I'm going to press stack, go over to calc 1, no frequency list. And then I'm going to scroll down to all of my information. So remember, we need to find the lower and the upper bounds first. So what I need to do first is I'm going to identify my IQR. My IQR is the lower quartile minus the upper quartile. We looked at that last lesson. So we're going to have 10 minus 6.5. 10 minus 6.5. That is equal to 3.5. Okay, so my IQR is 3.5. So in order to find my upper bound, I'm going to call it UB. I have to take my upper quartile, and let me write this over a little bit. You don't have to rewrite on your paper. I'm going to do it. So if we look at Q1, 6.5, Q3, 10, then I know that my IQR is when we take the difference, when you subtract them, and then we get 10 minus 6.5, and that is equal to 3.5. Okay, so now that we do that, we want to find our upper bound, and that's going to be equal to your upper quartile. The upper quartile is 10 plus 1.5 times your IQR, which is 3.5. So when I put that in the calculator, excuse me, that should be 10. Upper quartile is Q3. So I see that any number that is above 25 is an outlier, because it says any data that's larger than the upper bound is an outlier. If my upper bound is 25, then that means anything over 25 is an outlier. So now I need to find my lower bound. Your lower bound is your lower quartile, which is 6.5, and you're going to subtract 1.5 times your IQR. Ooh, excuse me. Made a mistake right there. Excuse me. That should have been 3.5, because your IQR is 3.5. That should be 3.5 here too. Excuse me. Okay, so what I'm going to do is I'm going to change this back 3.5. So anything that's greater than 15.25 is your upper bound. 6.5 minus 1.5 times 3.5. Anything that is smaller than 1.25 is an outlier. So anything that's bigger than 15.25 and anything that is smaller than 1.25 are your outliers. So as you can see, the outliers that I have is going to be 16. 16 is an outlier here. So what I have to do is when I draw, my number line, I'm going all the way from 1 to 20. Let's see if I have enough room. I have to do 2, 4, 6, 8, 10, 12, 18. Okay. So that's what I'm going to go by, and I'm going to go by twos. So I can actually go, I can do 1, 3, 5, 7, 9, so forth, so on. Okay, so my outlier is 16. So I'm going to put a star where 16 would be, in between there. I already know that my minimum, when I go here to stat calc, the smallest number that I see is 1. So I know 1 is going to just be a dot. The next biggest number that I see other than the 16 is going to be 14. So that is going to go there. And then I can put in my my Q1 and my Q3. My Q1 is 6.5. So that's going to be somewhere here. Remember, I'm doing this by hand, so I'm just estimating. My Q3 is 10, which is somewhere directly in the middle here. And then my Q2, which is my median, is 8, which is going to be somewhere here. You draw your whiskers here. When you have an outlier, you do not draw a whisker to the outlier. You just draw it to a whisker to the next number other than the outlier. Okay, so this is the way my Boxman whisker plot is going to look there. Okay, so if you have any questions, please write them down so that I can assist you later.